What if two moons spiraled around each other in a silent gravitational embrace while the pair they circled, two planets locked in their own eternal waltz, orbited twin suns that rose and set together across an alien sky? It sounds like the wildest fever dream of cosmic architecture, yet the laws of gravity don't just allow it. They practically dare the universe to build it. One viewer's comment dropped this exact layered riddle into our inbox, and it refuses to let go. Can planets be binary? Can a binary planet share a moon? Can moons themselves be binary? And the ultimate challenge, could a binary planet system share a binary moon, all of it orbiting a binary star? The answer is genuinely startling, because it drags us straight into the raw, untidy machinery of gravity at every scale, and reveals a cosmos far stranger, far more inventive than any neat diagram ever suggested. Let's peel this back layer by layer. Before we can even imagine shared moons, we have to settle what counts as a binary planet. No official definition exists in any astronomical handbook. The International Astronomical Union still hasn't drawn the line. But researchers lean on one unmistakable test: the barycenter. That's the common center of mass where two bodies truly orbit each other. When Earth and its moon tug back and forth, their shared barycenter lies deep inside Earth, about 2,900 miles beneath the surface. The moon circles a point buried in our planet's mantle, so the hierarchy stays clear. Earth dominates, moon follows. But flip the masses closer together, and everything changes. Pluto and Charon offer the perfect real-world proof. Charon holds roughly 12% of Pluto's mass, vastly more substantial than our moon relative to Earth. Their barycenter floats 600 miles above Pluto's surface, out in open space. Both worlds swing around that empty point, like dancers gripping hands and spinning across the void. By the outside barycenter rule, they form a genuine binary planet. The IAU's 2006 dwarf planet downgrade left Charon in definitional limbo. Yet planetary scientists still treat the pair as a matched set. Inside our solar system, no full-sized planets cross this threshold. Earth and Moon come closest but fall short. Out among the exoplanets, though, theory and simulations say otherwise. Protoplanetary disks can birth two similar mass worlds that lock into mutual orbit right from the start. We haven't caught one in the act yet. Transit timing struggles to separate a true binary planet from a planet plus huge moon, but nothing in the physics forbids it. Binary planets are allowed. They can exist. Now the next leap? Can two planets actually share one moon? To answer that, we step into the quiet power of the Hill sphere, the invisible gravitational boundary around any world where its pull rules. Beyond that sphere, a star's gravity eventually steals away any satellite. Earth's Hill sphere stretches about 930,000 miles. Our moon orbits safely inside at 239,000 miles. In a binary planet setup, the entire pair acts as one combined mass from afar. So the system inherits a single overarching Hill sphere. Inside it, each planet keeps its own smaller zone. A moon then faces three distinct fates. It might hug just one planet, tucked deep inside that planet's private Hill sphere, while the other world watches from a distance. Stable for now, though slow perturbations could erode it over eons. Or it could trace a wide path that encircles both planets at once. A true circumbinary moon, orbiting their shared barycenter. Stability here demands careful distance, at least 2 to 3 times the separation between the planets themselves, so tidal forces don't rip the orbit apart. Numerical models built on decades of celestial mechanics confirm these wide loops hold steady as long as they also stay inside the system's larger Hill sphere relative to the star. And we don't have to guess. Pluto and Charon already prove it. Beyond Charon itself orbit 4 smaller moons: Styx, Nix, Kerberos, and Hydra. each circling the entire binary pair as one. New Horizons flew past in 2015 and photographed them up close. They are living, breathing circumbinary moons of a binary planet right now in our own backyard. So yes, a binary planet can share a moon. Real examples exist today. But can moons themselves turn binary? The idea exploded in astronomy circles after a 2018 paper by Una Kohlmeier and Sean Raymond that asked, almost playfully, whether a moon could host its own satellite. A submoon, quickly nicknamed a moon by the internet. The math mirrors the Hill sphere logic. Give a moon enough mass and enough distance from its planet, and its gravitational reach grows large enough to cradle a smaller companion while fending off the parent planet's disruptive tides. Their calculations showed Earth's moon could theoretically keep a stable submoon out to about 185 miles, tiny but possible. Titan around Saturn could hold one clear out to 25,000 miles. Even distant Callisto might manage it. None exist in our solar system now. Early chaos probably cleared those orbits. But the physics says they could. A true binary moon raises the stakes further. Two moons of comparable mass orbiting each other, their joint barycenter then circling the planet. Tidal forces fight harder to pry them apart, yet simulations show stable windows exist if the pair stays massive, tight, and far enough out. Detecting one around an exoplanet remains brutally difficult. We still have only contested exomoon candidates, Kepler 1625b chief among them. And even those are Neptune-sized giants. A binary exomoon would be invisible to current instruments, yet the equations keep the door wide open. Now stack every layer at once, and the vertigo sets in. Could a binary planet share a binary moon? Picture it. Two planets of similar heft spin around a barycenter floating between them. Around that dancing duo, two smaller moons lock eyes with each other, their own barycenter tracing a wide, stable circumbinary path that wraps the planets at the required 2 to 3 times separation. Every scale must nest perfectly. The moons stay bound to each other yet far enough from the planets to dodge destructive tides. Their shared orbit around the planet stays inside the system's Hill sphere, so the star cannot steal them. Billions of years of tiny nudges and orbital resonances must fail to destabilize the whole arrangement. It is a gravitational house of cards, a symphony of nested clocks where one wrong tick could unravel everything. Recent N-body simulations of hierarchical systems show these configurations survive inside narrow parameter windows, but they are delicate, vulnerable to resonances that slowly amplify until catastrophe. Delicate, however, is not impossible. In a universe of hundreds of billions of galaxies, rarity still leaves room for millions of quiet miracles. Add the final flourish. What if the entire nested marvel orbits a binary star? Roughly half the stars in the Milky Way live in multiples. Our lonely sun is the outlier. Planets around binary stars settle into two stable patterns. In P-type orbits, the planet circles both stars together, the stellar pair sitting well inside its path. Like Tatooine's twin suns, now confirmed by Kepler, with systems such as Kepler 16b and newer test candidates spotted through subtle apsidal precession. The planet must stay at least 2 to 3 times farther out than the star's own separation to remain bound. S-type orbits hug just one star, while the companion stays distant enough not to wreck things. Models suggest Alpha Centauri could host them. Drop our full Rube Goldberg machine, binary planets cradling a circumbinary binary moon, into a P-type path around twin stars, and the hierarchy becomes breathtaking. 2 stars orbiting each other, the binary planet system circling them at a safe distance, the binary moon orbiting the planets, the 2 moons orbiting each other. 4 nested gravitational clocks ticking in perfect harmony. Stability studies confirm it works when each layer sits comfortably inside the one above, scales well separated, breathing room preserved. The math permits it. The cosmos almost certainly contains it somewhere. So why haven't we spotted any? Our tools still fall short. Transit dips and radial velocity wobbles barely tease out Earth-sized planets. Hunting a moon inside that signal is like listening for a whisper during a thunderstorm. The handful of exomoon candidates, Kepler 1625b still debated, fresh JWST, hints of sulfur dioxide clouds around hot Jupiters like WASP 39b and WASP 49ab, possibly betraying volcanic subio companions. Even a massive astrometric wobble around a brown dwarf hinting at a Jupiter half-mass moon remain unconfirmed. A true binary exomoon buried inside a binary planet around a binary star sits far beyond today's reach. Absence of evidence is not evidence of absence. Upcoming missions like Plato, now poised for launch late this year, will hunt Earth-like worlds with sharper eyes than ever, and future exomoon-focused efforts may finally pierce the veil. We are only at the beginning. Circle back to the original question, and the answers line up like stars in a constellation. Binary planets exist. We watch Pluto and Charon perform their duet every night through telescopes. Shared moons exist. Pluto's small companions prove it in real time. Binary moons are physically permitted even if unseen. A binary planet cradling a binary moon is allowed by every equation of celestial mechanics. Rare, fragile, exquisite, but not forbidden. And the whole delicate cathedral can rise around a binary star because circumbinary planets are already real and their satellite families obey the same rules. Gravity, given enough mass, enough distance and enough time, sculpts nested wonders that look borrowed from a mathematician's midnight reverie. Somewhere out there, right now, two moons may be whispering to each other while they loop a pair of planets that themselves circle twin suns. We have not seen them yet, but the universe has written the invitation. What does that do to the way you see the night sky? Does it make the stars feel closer, wilder, more alive with possibility? Drop your thoughts in the comments. What layered cosmic riddle would you love to see unpacked next? If this journey through gravity's hidden symphonies lit even a spark of wonder, hit subscribe, turn on notifications so you never miss the next deep dive, and share it with someone who stares at the stars the same way you do. The cosmos is stranger than we imagined, and it is waiting for us to notice.